Good afternoon, everyone. My name is Kazim Adegboyega, and I'd like to welcome you to the continuation of the Network Fundamentals webinar. So today we're going to be picking things up from where we stopped in the last webinar. In the last webinar, we started with definition of a network. We looked at the different networking devices to include router, a switch, a hub, a bridge, a repeater, so on and so forth. We talked about network topology. We looked at the topology types, right? And then we talked about the media types, right? So under the media types, we looked at media type to include the coaxial cable, the flavor of the coaxial cable, the thin net, the thick net, the UTP cable, shielded twisted pair, unshielded twisted pair. We also talked about Ethernet standard. We looked at fiber optics cable, and we also looked at the cable standard. If you're trying to prepare a straight cable, what standard can you use? And I mentioned the fact that we have two standard, the T568A standard and the T568B standard, right? So today we're going to continue with cable specifications, right? So there are a number of cable specifications that we have, and this cable specification is being defined by IEEE. We have the ISO, so on and so forth. So IEEE is responsible for defining Ethernet standards. So they have some specification that they've defined, specifications such as the 10 base T, right? 10 base T is for the twisted pair cable. There is the 10 base 5. There is the 10 base 2, right? So the 10 base 2 is for the thin net, so this is applicable to the coaxial cable type, right? And we mentioned that there are two types of coaxial cable. There is the thin net and there is the thick net. So the thick net, the IEEE specification for thick net is 10 base 5. IEEE specification for thin net is 10 base 2, right? And the maximum distance that you can run a thin net cable to before attenuation sets in is a 200 meters, and for the thick net you can run it to a distance of 500 meters. Next, let's take a look at WAN connectivity. So if you're trying to connect to the outside world, you need to get outside your local area network. So you're going to need a device that will connect you to the outside world, right? And that device is a gateway, right? Or you can use a router, as you can see here. So you talk to an ISP. Your ISP is going to help you with the connectivity. So they're going to give you some devices now that you can use to connect to them, and they are going to be acting as your bridge to the internet, right? So in the Cisco world, for instance, they like to refer to this device as the CSU DSU, right? But it doesn't have to be CSU DSU. So some ISPs don't necessarily need to use CSU DSU. You can simply connect the cable, the RJ45 cable that comes from their end to the back of your router or to the back of your cyber room device or the back of your gateway, whichever device you want to choose to use as your gateway, and that will get you onto the internet. So there's also this cable type. So I want to ask you now, what cable type is this? Has anyone seen this kind of cable before? So any idea of what this cable type is? Since we've talked about the cable type, we've looked at the coaxial cable, the UTP cable, the fiber optics cable. Okay, cannot see. Wow. Okay, cannot see my slide. All right. Okay, so is the slide, I don't know if the slide is visible now. Can't see anything. We can't see. Yes. Okay. All right. We can see it now. Good. So this is a cable type as well. So I don't know if anyone has seen this cable type before. Any idea? That is a spaghetti. Wow. All right. Yes. So it's a spaghetti. So it's not a cable type. Okay. All right. So let's move next to MAC addresses. MAC address. So what is a MAC address? A MAC address is a 48-bit number, that you have bound into every network interface card. We mentioned it in the last session, in the last webinar, that for you to be able to connect any device to a network, that device needs to have a network interface card. So the network interface card can be an RJ45 network interface card, or it can be a wireless network interface card. So regardless of the kind of network interface card that you have connected to your device, that network interface card must have a MAC address, right? So MAC address has a two-part address, right? So because of time, so I'm not going to delve too much into the details now, but just appreciate the fact that MAC addresses have two-part address. So one part is globally unique, and then the other part is being assigned to the manufacturer, right? So the other part of the address that is being assigned to the manufacturer is how you tell that this MAC address is from so manufacturer. You get the picture. And in its real sense, in real world, right, network interface card don't know anything about IP addresses, right? So all network interface card knows about is MAC address. But we know that we also need to have an IP address installed on that system for that system to be able to communicate on the network. So what does the magic? What gets the job done is a protocol that sits in between, right? So that protocol is called ARP, Address Resolution Protocol. So the Address Resolution Protocol, its job is to resolve IP address to MAC address and MAC address back to IP addresses. So that is the job of the ARP, Address Resolution Protocol. So in actual sense, when you send a data on the network, there's going to be a broadcast, that will be sent. Hey, this IP address, what is your MAC address? So if I intend to send data from computer 1 to computer B, computer 1 simply sends a broadcast, for the MAC address of computer B, right? And ARP now helps to probe for that computer B's MAC address, and then they can start to communicate. So that is what a MAC address is. All right, so how about the concept of full duplex versus half duplex? In a nutshell, duplexing is the function, it has to do with the function of the cables you have, your switches, and perhaps your router, right? So depending on the speed that those device type that you have on your network support, right? So full duplex means that my cable can send and receive at the same time, right? So if I have a device, let's say a cable that is running at a gigabit per second, right, and my device also can support that speed, it means that on that network I can send and receive at the gigabit speed, right? While full duplex on the other hand means that you cannot send and receive at the same time, so you can choose to send or receive at a time. So that's the difference between full duplex versus half duplex. And I mentioned what MAC addresses are earlier on. So this is an example of what MAC addresses looks like, unlike IP addresses. I hope maybe in some time in the future we can be looking at something that is IP address related, so we can get to learn more about IP addressing. But this is what a MAC address looks like, and every computer has something known as a MAC address table. And even your switches as well has what is known as a CAM table, right? So inside of a switch, it has a table of MAC addresses. So when you need to send data to a destination host on the same network, the switch will not have to broadcast all the time. It simply delivers the packet to that intended host. And also on your machine, there's an ARP cache. So if you log into your machine, log into the command prompt, you can try to do ARP-A, ARP space -A. That's after launching command prompt. I'm going to see if I can quickly right, I'm not sure I can do that now. All right, so if you can open command prompt, you open command prompt by going to run and then type in cmd, right? So from your command prompt window, you type ARP space -A and press enter. So if that system is connected to a network, you are going to see listings of MAC addresses associated with IP addresses, right? So that's how you view the ARP cache of your local computer. Microsegmentation is another. So microsegmentation, simply put, is a way of connecting systems to your switch on the network, right? And your switch is a better bridge. We explained the differences between a bridge and a switch in the last webinar, right? So we said a switch has more ports, more network ports, more network connection when you compare it to a bridge, right? So you can segment your network using a switch. And next, let's look at types of networks. There are two major types of networks. We have what is known as the peer-to-peer network. In a peer-to-peer setup, every computer is a server on their own, right? Or what determines if the computer is a server or a client is going to be determined by the kind of role that computer is running, right? So if I have three computers on my network now, and one of the computer has internet connectivity, the other computer has a printer connected to it, another computer say has a web server installed on it. So if all the computer on that network need to print, they are going to print to the print server. So the print server, the computer that printer is connected to, becomes a server. So you see, the role of the computer is determined by the service that computer is running. You get the picture. And in a peer-to-peer network as well, there's no centralized system, right? So each computer is responsible for managing his account database, right? So there's no way of centrally managing accounts on a peer-to-peer network. There's no way of centrally managing computers on a peer-to-peer network. So imagine having 100 computers on a peer-to-peer network. So to manage them, what do? So you need to start working from one system to the other, in order to manage those systems on the network. So that's a lot of work. So there's another network type is known as a client-server network or server-based network. So on a client-server network, usually you have a dedicated server, and all the other computers will be connected to that particular server. A good example will be a domain-based network. So in a domain-based network, you can have a domain, right? One computer is going to be dedicated as a domain controller, whereas the other computer now connects to that domain controller. So for those computers to connect to the network, an account will need to be created for them on the domain controller. So you see, if later in the future you need to manage any of the computers or any of the user accounts now, you can do so from the domain controller. You get the picture. So that is a server-based network. Another example that I can use here is DHCP service. So if I need to automate the leasing out of IP addresses, or I need to assign IP addresses to computers on my network, I can choose to do so statically, right? Or I can choose to dedicate a server, right, that would lease out IP addresses to clients on my computer. So DHCP server, it's also server-based kind of network, right? So that's the difference between centralized network, which is also known as server-based network, and a peer-to-peer network. So server-based network, client-server network is more organized when you compare it to a peer-to-peer network. Next, let's talk about the OSI reference model, shall we? What is OSI? OSI stands for Open System Interconnect, right? Open System Interconnect. And the OSI reference model is being brought about by a body known as ISO, the International Standardization for Organization. Or simply put, you can also refer to them as the International Standard Organization. So they are the one responsible for defining this standard that we have come to know as the OSI reference model. So the OSI reference model gives us a system that we can use to break down network communication. So it talks about things from the very top, where user interfaces with the network, to the very bottom, where you have your electronic signals, of network communication taking place, right? So that is what the OSI reference model was designed to do. It was designed to actually solve two needs, two problems, right? One of the problem is interconnectivity. Another one is interoperability, right? Interconnectivity meaning that different systems can now start connecting to themselves. So in the bad old days, when you have an IBM system, IBM is responsible for defining, for calling the shots, right? So if you need to have any other system connect to IBM, then you need to play by the IBM standard, right? So you cannot easily connect, let's call it a Dell machine now, to an HP machine, an HP machine to an IBM machine, right? So OSI, stop that problem. So they address that problem by giving the ISO address that problem by giving us the OSI reference model. So now when you have network interface card from HP can now communicate with network interface card from D-Link. You get the picture. So it enables interconnectivity and also interoperability between multiple operating systems. So it is very seamless now, not as difficult. If I want to connect a Linux operating system or a Linux box with a Windows machine, so I can easily get that done now. And what makes it seamless now is the OSI reference model. So OSI reference model is made up of 7 different layers. So you need to memorize this layer if you are looking to build a career in networking, right? So oftentimes people are going to be making reference to it. In fact, yourself, you need to make reference to it. If you choose to do some Cisco courses in the future, some security courses, even development, right? So there are times when you need to build an application that works in a particular layer of the OSI reference model. So you need to have a good understanding of how OSI reference model works, right? So and there is this there's this acronym that people use to remember the OSI reference model. You can either use we often use all people seem to need data processing. So if you're doing it top down, that's the top down approach. All stands for application layer, people for presentation, SIM for session, 2 transport, need for data for network, data for data link, processing for physical. Or you can choose to go bottom up, right? So if you're using the bottom up approach, then you can use please do not throw sausage pizza away, right? So that's a quick way of remembering the OSI reference model. So just quickly, let's run through the function of each of the OSI reference model, shall we? Beginning with the application layer here. The application layer is the layer 7 of the OSI reference model, and it helps us with interfacing with the network, right? So if you need to have an interface with the network, you need to start with an application, right, that you are going to use to connect to the network. Keep in mind that it's not all applications that are OSI aware, right? So that application needs to be Please do not throw sausage pizza. Okay, thank you at the BA for that. All right, so that application need to be a network aware application. A good example will be a web browser. So if I launch a web browser connect to the network, so you can take advantage of the OSI reference model. But let's take a look at an application such as a calculator. So if I open up a calculator or Microsoft Word by itself, so it's not a network aware application, so to speak. So they are standalone applications, so you don't expect to interface that with the OSI reference model. It don't have anything to do with the OSI reference model, right? So application layer in the nutshell refers to applications that are network aware that you can use to connect to the network. And the next layer down is the presentation layer. The presentation layer helps us to format data, right? So if I need to send data from computer A to computer B, the data that I'm sending need to be well formatted, right? I can choose a format such as .doc, that's a Microsoft Word document, or a .docx file. The person opening the file at the other end will also need to have Microsoft Word, need to have an application on their system that understand that formatting that I've prepared my application with. You get the picture. So the presentation layer helps us with formatting data, ensuring that we've chosen the right format, right? And encryption also sometimes takes place at the presentation layer of the OSI reference model. There are times when you might also need to compress your files to save disk space, right? So compression also happens at the presentation layer of the OSI reference model. The next layer down is the session layer. The session layer doesn't do much. The session layer is responsible simply for establishing session, right? So a computer A wants to communicate with computer B. A session needs to be held. A session needs to be formed between the two computers, right? Can't hear sounds. Hope we can all hear me. Adiola is having issues with sounds. Okay, good. All right, so the session layer is a layer that you use to establish connectivity. I don't want to be too technical here, but let me throw in some little bit of technical words into this now. If computer A wants to establish connectivity with computer B, computer A will send a data type, a type of packet known as a SYN. A SYN means that I want to start talking to you, computer B. So it's more like an hello, right? And then computer B needs to acknowledge it, by sending an ACK back to computer A. So you see, the first computer sends a SYN, the second computer sends an ACK, and then the computer that initiated the conversation will need to also acknowledge that handshake, right, by sending an acknowledgement back. So once that happens, you have what is known as three-way handshake, right? A session is therefore being formed between the two computers. So it's also possible for computer B, or computer D rather, to want to communicate with computer A. So what ensures that computer A does not break its session with computer B is the session layer, right? So it is also responsible for also killing sessions, right? So when session needs to be destroyed, the session layer also does that, right, using the FIN packet, right? Next layer is the transport layer. The transport layer is the layer 4 of the OSI reference model. And sorry, just quickly before I move into the transport layer, keep in mind that this first three layer of the OSI reference model happens at the user end, right? So this does not have anything to do with your network devices, so to speak, right? So it happens at the user end before a user sends the data. So it takes care of the application layer thing, the presentation layer concept, the session layer concept is being handled. The next layer, the transport layer, I said is the layer 4, and this defines how information is being sent, right? Information can be sent reliably or unreliably. Keep that in mind. So there are times when you want to send the data And what is key to you, what is of utmost importance to you, is reliability of the data that you want to send, right? So you don't care if the data gets there on time or not, but you want to really be sure that that data, gets to the intended destination or the intended recipient, right? So it means that you're choosing reliability over speed, right? So there are two protocol that is key to note here. The two protocol types include TCP and UDP. TCP and UDP, right? Transmission Control Protocol and User Datagram Protocol. The Transmission Control Protocol is considered to be a reliable protocol, right? Very reliable, but it is a slow protocol, right? So on the other hand, UDP, User Datagram Protocol, is very fast, but what it lacks, but it's very fast, but it is unreliable. So what UDP lacks in terms of reliability, it tends to make up for it when it comes to speed. So you need to ask, maybe I should paint a scenario here. A good example will be if I'm trying to download something from a web server that I have on the internet. I'm trying to download, let's say, Ashem.com from Ashem.com's web server, or a web server on the internet that is hosting Ashem.com. I want to ensure reliability. Maybe there's a page that I'm looking for on Ashems.com's website, right? So I don't want the page to be cut in half. So if it's being cut in half, then the whole content is not made available to me. So reliability is of the essence here, right? So I probably want to go with TCP over UDP. Another very good example is carrying out an online transaction. So I need to transfer money from my savings account to my current account. I need it to be reliable, right? So I need reliability here, because if money money leaves my savings account and does not get into my current account, then there's going to be some issues. Although there are technologies, there are concepts that is being built around databases that can take care of those kind of problems. But you get the picture here. And a very good example of an application, an applicable concept to using UDP will be invoice over IP. Just like we're doing now, so we're having a conferencing now, you're all listening to me right now. We don't care about reliability so much. Yes, we want to ensure that we have good internet connectivity, but if I happen to drop a packet, maybe my router, my gateway that is getting me out to the internet happens to not deliver one of my packets. I want to say, how are you? And what you catch is just how you. So the R, is missing. I mean, there's no point resending the R to you at a later time. It makes no sense, right? So you just want to carry on and then hope that the connectivity will be better moving forward, so you can hear me clearly moving forward. You get the picture. So those are time when you want to consider speed over reliability. Another very good one of when to use UDP is in the case of DHCP, Dynamic Host Configuration Protocol. I mean, when you want to, if imagine having 100 computers on a network, we know assigning IP addresses to them statically is going to be a lot of work. So it will be better for you to automate the process by setting up a DHCP server. Now, when you set up a DHCP server, you need your DHCP server to quickly be able to give out IP addresses to computers on your network, right? When people boot up their computer, you automatically, instantaneously, you want them to get IP addresses, right? So in that example also, you want to ensure that speed, becomes the essence. Speed is more important than reliability, because it's possible for your computer to be booted up and not get IP address, right? But the chances are very slim. Maybe on a network of about 200 computers, it's possible to boot up the 200 computers, and maybe one or two of those computers might not get IP addresses. And your technical people can then look at resolving it, flushing the cache, renewing the address, disabling the network card, and re-enabling it it, you get the picture. So those are two protocols that gets the job done at the transport layer. So just visualize the transport layer more like the postman, right, that gets your letter delivered. I'm looking to send letter from Lagos to Abuja, right? So how does it get to Abuja? You need a post service, right? You need a postman that will deliver your data. So the that's analogy, you can apply it to the transport layer here, the transportman, that postman that gets your data delivered. Next layer down is the network layer. The network layer is the layer 3 of the OSI reference model, and the network layer is responsible for logical addressing. Now, when I say logical addressing, I mean IP addressing, Internet Protocol addressing, right? What is an IP address for those of us that are new to networking, right? An IP address is an address that is required for use on a network. For computers on a network to communicate, one of the key requirements is that each of the computer need to have an IP address assigned to it, right? So for it to be able to communicate. So that is what an IP address is. I think we should leave it at that and not try to delve into the matters of type of IP addressing. Because of time here, there are types of IP addresses, there are classes of IP addresses. You need to be able to differentiate between the different classes, know when to use a private address, know when to use a public IP address. You get the picture here. So, but in a nutshell, the meat and potatoes here is for you to realize the fact that under network layer is responsible for choosing addressing that you are going to use to send your information with. The analogy that I mentioned, that I used earlier about the postman, you need a postman to help you deliver a letter. That letter that you're looking to deliver need to be addressed, right? So there has to be a source address where the letter is coming from, where the letter is originating from. Then there has to be a destination address too as well. So the postman knows how to get the letter delivered. You get the picture. So what is responsible for doing that is the network layer. And a good example of a device that gets that job done, that does the work, that works at that layer of the OSI reference model, is a router. A router, right? A router. Keep in mind, a router does not necessarily have to be a Cisco router. Yes, Cisco is just more popularly known when it comes to routing, but there are some other vendors out there that also that are also into routing. In fact, you can even make your Windows box or your Linux box act as a router, right? So let's move next to talk about data link layer. Data link layer is the layer 2 of the OSI reference model, and this is also responsible for addressing, right, for transmitting data. um, I know some of you might be confused right now. Network layer does addressing, data link layer also does addressing. I mean, how is that possible? Yes, there are different types of addressing that these guys handle. At the network layer, you have logical addressing, IP addressing, right? And at the data link layer, you have physical addressing, right? So the physical addressing is that MAC address that I mentioned earlier, right? Every network interface card comes with a MAC address, right? So another name for MAC address is a physical address, right? So if you don't want to call it physical address, you can refer to it as a MAC address, right? Or an hardware address. So every computer, every network interface card comes bundled with a MAC address. So the MAC address is what is responsible for unique identification, right? Unique identification. And the protocol that sits in between these two, that helps us differentiate IP address from MAC address, or that helps us query the MAC address of a computer is ARP, Address Resolution Protocol. The address resolution protocol is what is going to send the probe to the system, to get out its MAC address. You get the picture. So a good example of devices that works here is your switches, your layer 2 switches, your network switches. So switches use MAC addresses to communicate, and not logical addresses. So logical addresses comes to work when you're trying to reach a computer, a host outside of your network. Here is what I'm going to do because of time now. So I need to confirm from ADBA. I think we should. What I'm going to do is offline. I can try to, because I need you to really understand the practical application of the OSI reference model. So once we're done with the webinar, I'll try to have a recording done of the practical application of the OSI reference model, so you can, I can try to drive home the point using how we can apply it practically, so it makes more sense. You can connect the dots better that way. And you can download the video now from the Hashem Yammer page. So I think so if DBA can help me confirm that, if that's okay. So the next layer is the physical layer, right? So the physical layer is where your network signals takes place. You need those signals to be sent over the network. So those signals are going to be sent using over your wires, right? Or even wirelessly, using air as the medium of communication. You get the picture. So that is in a nutshell what the OSI reference model entails. So the take-home point here is OSI was designed to meet a need, right? To ensure that different manufacturers can produce equipment that can talk to themselves, right? The D-Link can have their network interface card interface with a network interface card from HP. You get the picture. And also to ensure that operating system type different operating systems can talk to themselves. So that way it ensures that, in fact, vendors can even focus better. That way a vendor can say, I want to start building an application. I want to build a device that is going to talk just at the network layer. You have vendors that work with devices at the layer 2. You get the picture. A good example, Cisco is a vendor that majors at the layer 3 and perhaps the layer 2 of the OSI reference model. You get the point here. So that is what we're going to be looking at today. So I hope this has been informative. And I'd like to thank you for your time, and I'd like to apologize once again for the latency, the network interruption. So I can pass control now to Chisom for any last words, and maybe I can take some of your questions afterwards. Hi, Chisom.